Hello students, today's discussion is magnetic induction at axial point of circular coil. In the last lecture, we have discussed that. So, magnetic field induction due to at the center of circular coil. Okay, at center of circular coil. At center of circular coil. So, this from here just have taken as this is the current carrying coil. Okay, so its current is passing this way. Which direction is this? It's a clockwise direction. So clockwise direction means what? I should use that Ampere's curly fingers rule, right hand curly fingers rule, like this, and this is into the plane. Okay, the direction of current like this. Okay, so like next one is about it's a out, for example. This is okay, so its direction is opposite. It's a dot, correct? Because in the direction curly finger, so it's what? Out. Okay. So for both the cases, the magnitude is E is equals to mu naught Ni, capital letter Ni. Small n don't write because small n is what? It's the number of turns per unit length. Okay. Mu naught Ni by R is a form. It's a magnitude. So what is its direction? Into the plane. Okay. So minus k cap. So for this one, B is equals to mu naught Ni by 2R dot out the plane. Okay. So this is first one, and next second, these are the magnetic fields due to first and second coils. So now the situation is, what is the magnetic induction at axial point of circular coil? Okay. So this is what some circular coil is taken, is the circular coil. Okay. Coil is like this. So its coil is means what is like a cross, means this is the like a cross section if you observe this. Okay, so if you want to find the magnetic field induction, this is the axis, is the center. So let it be the current is passing in this way. Okay, any direction depends on the direction of magnetic field, we can find it. Okay, so I want to find this, the magnetic field. So at this position, this is the axis. At this position, I want to find here. Okay, so at this position, it means now this is the point. Is the point P. My question is, so first one, Biot-Savart law. It's for all the cases for the current carrying wires. Okay, conductors, for all the cases. So we have been discussing Biot-Savart law, based on Biot-Savart law. Okay, Biot-Savart law is what? So first one, DL bar means what? Current element, direction of DL bar, and next one is what? Angle between the DL bar and the line where you want to find the magnetic field. Okay, so the angle is, that is very important. Choosing the angle is very important. So I am choosing about, there is a length element. This is the length element. It's a length element. So what? Okay, so where you want to find the field? Here. So this is the length element. What is the direction of length element? Like this. Okay, so it's what? Now I want to take on this. This is the line joint from here. Yes. So it's what? You can take about this. Here is it's a radius. So this I can say it's a radius. And next one, this distance is x. X or L or D, anyone take it. Okay. So this will be under root of r square plus x square, square root of r square plus x square. Now the biggest question is what? Sir, if it is the coil is like this. For example, if the coil is like this, current is passing in this way. Current is passing in, means the field direction is what? Like this. But if we choose any length element, this is the length element. For this length element, this cross section means what? At this point, here is the length element. With this is making an angle theta. It's what? 90 degrees. So that is what? Sin 90 is what? 1. Means dB magnetic field induction D is equals to here directly I am writing about the magnetic field induction. Okay, dB is equals to mu naught by 4 pi, naught by 4 pi. Okay, I sin theta by r square is the relation. So this is the sin theta is angle between again I am saying this one. So dl bar and r bar, which means we used to write about the vectorial form mu naught by 4 pi. Okay, so next one I into dl bar cross r bar by r cube is the form. Okay, so is the vector, the angle between these two, this is a plane dl bar cross r bar is the vector product. This is the plane. Which plane is this? With this one, this is the plane. So the direction of magnetic field is what? The direction of magnetic field, so direction of magnetic field is, we can take perpendicular to this plane, which means extend, right? Okay, one is it. So is the perpendicular to this plane. This is the perpendicular, like this. Okay, it's a perpendicular. So perpendicular here we can say, so perpendicular means this is the perpendicular. It's what? dB is a perpendicular to this. This dB, okay, so this dB, what is that? It's a dB, direction of magnetic. It's a direction of magnetic. So now we can take x and y axis. Okay, so this is what? Vertical one, the horizontal. Okay, so which makes, this is the angle theta. Yes, here is the theta. Actually here this is what? Here theta is what? 90 degrees. That's what we are taken as sin 90 is what? 90 degrees. So dB is resolved into two components. So this is what? It's a dB cos theta. Next one is sin theta. It's a dB sin theta. This is perpendicular to this one. But this line and this one perpendicular, it's a theta. This will become as 90 minus theta. Is perpendicular to this dotted line. So this must be what? Theta. dB is resolved into two components, dB cos theta. Next one is what? dB sin theta. Like infinite parts, all of them are divided. I mean to say. So now we can see this one. So it's what? Like this is what? Like dB. It's what? Vertical upward, and next one like this. And this one, due to this one is like, and next one due to this part is what? Downward. Next, okay, so next downward, next, so it's what? Again. So this is what the resolution is, like this will be taking place continuously. So these vertical components are getting cancelled. Vertical components are getting cancelled. So what components are there along with this one? Only dB sin theta. How many dB sin theta we have? Infinite number of dB sin theta. How do you add infinite number of dB sin theta? Infinite terms, by taking integration. Okay, integration of dB sin theta will be my next concept. Okay, so that's what I'm trying to say here. Right? Yes, so the magnetic field B is equals to integration over dB sin theta. Okay, so what dB sin theta? Yes, B is equals to, I can write this one. So integration over dB means what? Mu naught by 4 pi. Mu naught by 4 pi. I dl, okay, sin 90 is 1 by r square. R square means what? Under root of r square plus x square. Okay, so this is what? R square plus x square whole square into sin theta. Sin theta is what? Opposite r by, so under root of r square plus x square. Okay, so this one square and root cancel. These two will get cancelled. So then I can write B is equals to magnetic field induction. B is equals to, okay, mu naught by 4 pi, mu naught by 4 pi I, okay. So this is what I, mu naught I by 4 pi dl, okay, by under root of, so again R also, so under root of R square plus X square to the power of d by 2, okay. So this is square, R square plus X square, and R square plus X square to the power of 1 by 2 will become as R square plus X square whole power 3 by 2. B, magnetic field induction B is equals to, this is what integration, correct? So I am writing as this, mu naught I by 4 pi, okay, R, next one, R square plus X square to the power of 3 by 2, integration over dl. dl is from where? So from 0 to pi r. dl is what? Length. So dl like infinite terms if we add, so it's what? Up to circumference. So this will become as B is equals to mu naught I by 4 pi, okay, next one R by R square plus X square to the power of 3 by 2, next into integration over dl is L, limits from 0 to 2 pi r, I can write it as, it's a 2 pi r, okay, by 1s are, so this is 2 pi, 1s are by 2 r, okay. So B is equals to mu naught I by, okay, mu naught I, so R square also, mu naught I, R square by 2 into R square plus X square to the power of 3 by 2 is the relation. So what is the magnetic field induction? At a point on the axis, okay, at the axis, so this point I have chosen as it's a P. So at this point, magnetic field induction B is equals to mu naught I R square by 2 into R square plus X square whole power 3 by 2. For n number of turns, if you write n, capital N or small n, definitely it's a capital letter N, okay. So I can write as this one, for n turns, capital N number of turns, So what do you write? So this will be mu naught n I R square by 2 into R square plus X square to the power of 3 by 2, okay, is the relation. So mu naught Ni R square by 2 into R square plus X square whole power 3 by 2, okay. So now this is the relation to the magnetic field due to a current carrying coil at a point on its axis which is passing through its center. So magnetic field is this. So next one, I am coming to this point is what? Sir, this magnetic field induction, very first case I am taking as a case 1, I am writing this B. So magnetic field induction B is equals to mu naught Ni R square by 2 into R square plus X square to the power of 3 by 2 is the first case, okay. Now, so it's no issue for this one. This is what for n number of turns. Now if you are taking about, this is the ring, okay, for the ring. So if you are moving away from this one, at what distance from the center the field is maximum? At what distance from the center the field is maximum? Case 2, okay, field is maximum, B maximum. When B maximum, for B maximum what to do? The first differentiation of B must be is equals to 0. That is X is equals to R by, okay, the case 2. X is equals to R by root. Next one for case 3. Okay, these cases are very important. Careful. Case 3. So for example, this is the coil. The coil is taken. If X is very much greater than of R, means for example, ring is here. If I find that for the long distance means what? As compared with the distance of X, R is very small. Okay, so from that case, I can write on this one B is equals to mu naught n, capital letter N, I r square by 2 into r square plus x square whole power 3 by 2. Okay. So, mu naught Ni r square by 2 into r square plus x square whole power 3 by 2. So, in this case, I have to use for this one here r square plus x square to the power of 3 by 2 will become as x square to the power of 3 by 2. 2 and 2 cancel, it's a x cube. Okay. So, it would become as x cube. Now, we can write on this. The equation is B is equals to mu naught Ni r square by 2, r square plus x square means what this become as x cube. Okay. So, mu naught Ni r square by 2 x cube is the relation. Okay. So, next I am moving to this one and dividing with 2 pi to get some relation. This is what an axial point. P at axial point is equals to. Okay. So, what do you write? Mu naught Ni r square by 2 x cube, okay, 2x cube multiply and divide with the pi, say multiply and with divide with the 2 pi. Then what do you say? B at axial is equals to mu naught Ni r square into 2 pi as it is. This is what 4 pi to x cube. Okay. So, you can observe this is pi r square. What is the pi r square? It would be a area. Okay. Now we can write this. B A is equals to mu naught by 4 pi. Mu naught by 4 pi. Mu naught by 4 pi. Next one. N I A into 2 by what? X cube. So, do you know what is NIA? It's a magnetic moment, current carrying conductor. So, its magnetic moment NIA. N is the number of turns, I is the current, A is the its area. Okay. So, this is B is equals to B at axial is equals to mu naught. Okay. NIA mu naught by 4 pi. Okay. So, this is what 2m by x cube. So, you observe this equation. So, have you seen this type of equation anywhere? Yes, sir. So, this is what mu naught by 4 pi 2m by d cube or mu naught by 4 pi 2m by x cube means what? At a point on the axis of the ring, axis of the where is the magnet? Choose this coil. So, for this coil is what? At this position, find this one. Okay, what is the, this is what? B axial. This distance is what? X. So, this is what? It's a R. Okay, it's a R. Then what do you say on this? So, it acts like a magnet. Which one? Coil acts like a magnet. Coil acts like a magnet. There are the north and south poles. Okay, so now north and south poles means what? Already we discussed it earlier. Okay, so if it is, this is south. Okay, if the current is passing through the coil towards to your face, if the coil is towards to you, current is what? In the clockwise direction. Clockwise direction means it acts like a south pole. So if the current is what? Anti-clockwise direction, the top face or the first face which is towards to you acts as a north pole. Okay. So, this from this condition it's a case 3. So, just we have proved that what in terms of magnetic moment. Not only that coil acts like a magnet. Okay. So, next one as a case 4 which is the last one from this. So, fourth case. So, here case 4. If x is very much smaller than of r. Earlier case x is very much greater than of r. Now x is very much smaller than of r. So if it is x is very much smaller than of r, which is very small, means very small. Okay. So very small means what? Here we can say r square plus x square to the power of 3 by 2. Okay. R square plus x square to the power of 3 by 2. So in this case, x is very much smaller, very smaller. So in very smaller means what? I am taking about magnetic field. B is equals to B and axial is equals to mu naught by, okay, mu naught Ni r square by 2 into r square plus x square to the power of 3 by 2. Okay, carefully you observe this one. Okay, so I am bringing this one r square outside. This is what mu naught Ni r square by 2. So this r square you bring out, r square to the power of 3 by 2 times of 1 plus x square by r square to the power of 3 by 2. Okay, this cancel. Say r cube and r square means become as a r. So this is what mu naught Ni, okay, mu naught Ni by 2r into 1 plus x square by r square to the power of minus 3 by 2. You can check this one. This become as a minus 3 by 2. But this is what it's a magnetic field at the point on an axis. So what is this one? This is what magnetic field a point at the center of the current carrying coil. So BA is equals to mu naught Ni by 2r, correct now? N is what? Number of turns. Okay, so BA is equals to, we can write, it's a, so B naught times, okay, 1 plus x square by r square to the power of minus 3 by 2. So it is for a very small one. So I have to use that binomial expansion. Okay, so what is that binomial? 1 plus x to the power of n is equals to, you can write 1 plus nx. This n comes first. Okay, so BA is equals to B naught times 1 minus, okay, 3 by 2 x square by r square is my relation. So for this is what like previous questions it is there. What is the ratio between the magnetic field at a point on the axis to magnetic field at its center? BA by B naught is equals to 1 minus 3 by 2 x square by r square.